Hi guys, my name is Sergey. I'm from Fuse Servicing Corporation. I am lead of technician, and today we will have discuss about systems evacuation the right way. Before we start talk about system evacuation, just a few things. Restroom there, kitchen behind me. If you want, just drink water, coffee or tea, just take it. Okay, system evacuation, the right way. Let's start. Okay, the first thing is safety first. These are some of the safety hazards assisted with vacuum and the equipment used. Pressure in the systems. If leak test pressure from the systems is applied to the vacuum pump and hoses, a few things could potentially happen. Sudden oil discharge from the exhaust port is a very likely occurrence. Internal damage to the pump is possible. Some vacuum pump hoses are not pressure rated. If pressure is applied, this could fault suddenly. Pump exhaust gases can contain refrigerant, pure nitrogen, oil. Before you start doing any vacuum process, make sure systems, I mean condenser coil, condenser unit don't have a pressure. As pressure it's zero. What is vacuum? In the HVAC and refrigeration industry, vacuum is process of reducing pressure in the refrigerant systems to a specific pressure that is below atmosphere pressure. The industry often refers to vacuum as pulling a vacuum or evacuation. Why should we put a systems under vacuum? Customer satisfaction. After completed installation or repair. Customer A. Equipment is soon broken, occupants are hot or cold, product out of temperature range, production line stopped, tells potential customers to use someone else. What's happened if you are, for example, if you are installed brand new systems and if you are forgot vacuum, any air, water, gases or something like that, and open the valve from condenser unit systems, it will be start works, but as soon after maybe few years systems it will be broken. Filter dryer maybe will have a restriction. TXV valve maybe have restriction, or systems start works but not like efficiency system. If we speak about AC, evaporator coil cannot drop 20 degrees temperature from return and supply. That's it. What is a good vacuum? Good vacuum, it's when your for example, if you are install brand new systems, your line set not more than 100 feet, and you start turn on your vacuum machine, vacuum pump, and vacuum should be like 10-15 minutes, not more. You need to drop your vacuum gauge until below than 500 microns. Shut off valve from vacuum pump, or just closed some switch on your fieldpiece gauge, and wait 10 or 15-20 minutes, and microns cannot go up more than 1000. Vacuum should be hold between 500 to 1000 microns. How do we know when the vacuum really is good? We can imagine, or we can use vacuum gauge like this one, MG44. This is vacuum gauge of Fieldpiece. We can put this gauge to our gauges or to recovery vacuum machine, or to some valve from condenser unit. Since most technicians are not physics and cannot see if any non-condensable remain in the systems, they need to use a gauge to measure a pressure in the systems. A maximum pressure value under vacuum is set by the equipment manufacturer of the refrigerant systems. The manufacturer's specified pressure or lower should be achieved in the systems at the time of installation and repair. The accurately measured pressure in the systems under vacuum and Micron gauge is used. The typical specified pressure value for most equipment is 500 microns of pressure above absolute zero. At 500 microns of pressure, the boiling point of liquid water is about -12 Fahrenheit or -24 Celsius. How do you know when the vacuum really is good? For example, atmosphere at sea level, it's 660,000 microns. It matched 212 Fahrenheit. 500,000 microns matched 152 Fahrenheit. And for example, 500 microns, it's -12 Fahrenheit or -24 Celsius. Why a digital vacuum gauge? Why it's much better to use digital vacuum gauge than old one school like on the picture? Because on the picture you don't see any microns. You can just take a look. It's maximum negative, it's 50,000, almost 51,000 microns. But when we start vacuum standard for refrigerant systems, it's 500 microns. On old school gauges, you cannot see when your vacuum pump drop pressure to 500 microns. What other tools and supplies do we need? We need fieldpiece gauges. We need to use hoses for gauges. We need to use vacuum pump, huge size of vacuum gauge, Micron gauge, tool removal valve core tool, and oil. How often do we need to change oil? It depends how big systems. How often we use our vacuum machine, and how many is it wet or dry systems was before when we start to use vacuum pump. What does a vacuum pump do? The vacuum pump causes a flow of gases towards the pump by creating pressure differential between the pump and the systems. To start the flow, differential between the pump and the systems. To start the flow, the vacuum pump creates a low pressure hole by ejecting molecules out of the pump into the atmosphere. In the diagram, we see the lowest pressure is at the pump and the highest pressure is in the system. The gases in the system slide down into the low pressure hole as the gases try to equalize pressure. As the pump runs, the hole keeps getting deeper as the molecules from the sealed systems are removed. As the pump ejects molecules out of the system's pressure gets lower. The deeper the hole gets, the lower the pressure differential between the systems and the pump becomes. As the pressure difference decreases, the number of molecules available to the eject from the pump decreases, so the process slows down. Gas ballast. Right side, it's gas ballast for old one style pump, and left one how it looks like on Fieldpiece vacuum pump. On the one feature some vacuum pump have in common is in a gas ballast. The gas ballast is designed to extend the life of the vacuum pump oil when a refrigerant system is wet. To do this, the gas ballast allows a small amount of air into the pump housing to keep moisture from condensing into the oil. To use the gas ballast, open the valve, like right now it's open, this one is closed, open. To use the gas ballast, open the valve prior to starting the vacuum pump. When moisture vapor stop coming out of exhaust or at about 3000 microns, whatever comes first, close the gas ballast valve. If the system is dry, use of the gas ballast is not necessary to the desired vacuum level. The Fieldpiece gas ballast is used much easier than old style of the pump. When we need to use gas ballast, if we are come to the field and figure out refrigerant AC systems has a leak, and we decided just fix the leak and refill refrigerant gas, we know probably the leak was from evaporator coil. Maybe systems it has a water leak. I mean, maybe systems has a moisture inside because leak was from evaporator coil. We supposed to be use gas ballast to save oil and decrease time for vacuum. If we are installed brand new system and we exactly know our line set is brand new, we don't need to use gas ballast because vacuum time it should be just 5-10 minutes if systems are not more than 2, 3, 5 tons. Micron gauge location. Using what we learn about the pump, where do you think is an ideal gauge location for accurate systems measurement? Located at the pump will measure the lowest pressure. It means if you will be put your vacuum gauge on the pump like this one, it will be lowest pressure. If you will put Micron gauge to core removal tool, on the core tool side port measure its higher pressure than pump. Located in the systems will measure the highest pressure in the systems. Located as far away from the pump as possible to get an accurate measurement in the systems. Large differences in thousands of even tens of thousands of microns can exist between the pump and systems while the pump is running. Any Micron gauge is better than no Micron gauges. External stand-alone Micron gauge is preferable when compared to a Micron gauge in a manifold. Hoses and manifold can leak under vacuum. Small hoses and internal manifold passages reduce flow, which increase time. Need to have minimum of 1 micron resolution below 1000 microns. Need to be high accuracy gauge. Need to measure down to less than 100 microns. A full range gauges show the progress from atmosphere down to final level. If a connection is loose or other major leak is present, the full range gauges reading will stall, which indicated there is an issue that needs to be addressed. What can core removal tools do? Core removal tools, originally designed for replacing leaking cores while the system was under pressure, removes the core for increase removes the core for increased flow during vacuum. Removing a valve core and core depressor increase the capacity of water hose from 0.2 cubic feet per minute to 0.8 cubic feet per minute. Became a useful tool to increase the speed of other tasks while servicing refrigerant system. Refrigerant recovery, refrigerant charging, leak testing, systems isolation from atmosphere, gauge isolation, any others, and others. The side port has a valve core installed and is connected to the systems when the ball valve is closed. Should be rated for vacuum, quarter turn valve for fast operation, useful on manually operated service valve to eliminate stem leaks when doing service. Valve, this one is core removal tool. Valve core removal tool are universal, first and last of tool for many aspects of servicing refrigerant system. This is how it works inside a core removal tool. You need to put this tool removal for any valves on any condenser unit. Just open the small pieces which installed inside to the valve. Open it and close this valve. And after that, you supposed to be connected your hoses and do it vacuum. Put stem pulls back with core. Ball valve close. Stem and core leave. Hose connected to end of the ball valve. Ball valve is open. Pressure is removed by vacuum pump. Vacuum through charging manifold. We are supposed to be connected to our manifold gauge to refrigerant systems. Red hose we're supposed to be connected to liquid line. Blue hose we have to connect it to vapor line. And black hose we need to connect it to our vacuum machine. We can put two micron. We can put 1 or 2 micron gauges. It doesn't matter. We can put micron gauges on liquid or vapor line. Or if we don't want use our gauges, we can connect it vacuum pump directly to refrigerant systems. For example, we can put hoses to vapor line and vacuum pump, and to liquid line we can install just vacuum gauge. It's much easier and much faster. Or we can vacuum systems through multi-type hoses from vapor line and liquid line. It will be much faster. How much faster are large hose? Quarter, 3/8, half, and 3/4. How it works? There are several factors that affect speed with the process of vacuum. Hose diameter is one of them. The term used for measuring flow under vacuum is condensed speed. According to the book Review of Vacuum for Service Engineers, the condensing speed of 1/4 outdoor dimension refrigerant tubing is too small to be useful as a connection line to a systems. Flow rate a hose is one piece of the equation. We still deal with the assembly, which includes connection on both ends. These valves are with the service port, valve core removed. The flow valve of the hose alone is higher than assembly value. If you will be do it vacuum from 1/4 inches hose assembly, speed around 0.8 cubic feet per minute. If hose will be 3.8, 1.5 cubic feet per minute, speed increased almost twice. If we will use half hose assembly, speed will be 3.0 cubic feet per minute. And if we will be use 3/4 hose assembly, speed will be 5 cubic feet per minute. If we will be use short vacuum hose and bigger size, we will be decrease our vacuum time. Larger hoses increase speed due to less resistance to flow. Flow is the result of differential pressure between 2 points. Pressure is the result of molecular collision with the walls of vessel. When the hose size is increased, it reduces the frequency of wall-to-molecule collision. Decay test, also referred to as a rise test. This test is to see what is remaining in the systems after the pump is disconnected from the systems and turned off. To make the test as accurate as possible, it's advisable to use a minimum amount of connection between the systems and Micron gauge. It means if you turn on your vacuum machine and you see on your Micron gauge like less than 500 Micron, and shut off your some valve from gauges or just shut off a vacuum machine, Micron cannot increase more than 1000. If microns increase more than 1000, it's a lot of moisture in the systems, or system has a leak. It may be leak from any connection of gauges, hoses, or just systems has a leak. Decay test. Take a look. 7. Okay. If after minutes, when we shut off vacuum pump, our microns stay between 500 to 1000, it's good. If microns go up to 5000, it means moisture there. And if microns go up to more than 25, 10, 15, 25,000, it means we still have a leak. We need to figure out where is exactly leak, fix the leak, and turn on machine back. Are the tools working? Periodically testing components to make sure they are working is important. The vacuum pump and oil can be tested by connecting an uncontaminated digital vacuum gauge directly to the pump and running it for a few minutes. The gauge should be capable of reading down to 50 microns in 1 micron increments for this test. The pressure should fall fairly quickly and ultimately go to 50 microns or below. If the pressure does not go to 50 microns, first change the pump oil. If the pressure does not fall to 50 microns after changing the oil, the pump and gauge are suspect. Most HVAC and refrigerant pumps will create less than 20 microns if run long enough. Tool maintenance and storage. Maintaining tools, it's necessary to keep them working when they are needed. Vacuum pump. Oil change are needed, but not necessary every time it is used. Use a uncontaminated vacuum gauge at the end of the job to evaluate oil in the pump. If the pump will create a pressure down to 50 microns, the oil is in good shape and can be used again. If the pressure won't get to 50 microns fairly quickly, the oil needs to be changed. Change the oil at the end of the job when the oil is warm and any particulate is likely to be in suspension. After the oil is changed, run the pump for 20-30 seconds with the caps in place so the oil in the actual pump gets exchanged with the oil in the reservoir. Periodically do a physical inspection on the pump for damaged cord caps and repair or replace as necessary. Oil change with Fieldpiece vacuum pump are easy and virtually mess-free. Gauges. Change any gasket or rings as necessary. Clean the sensor if oil contamination occurs. Hoses. Replace damaged gaskets, rings as necessary. Inspect for physical damage. Store all hoses with the end closed or kept. What if liquid water is in the systems? If liquid water is present in the systems, get 99+% of liquid water out prior to start the pump. Very small amount can be removed with the pump, just very small amount. A large amount will be time consuming and use a lot of oil. Expect to change the oil in the middle of the process, so have plenty on hand. Blow liquid water out with nitrogen. Use heat to 212 Fahrenheit to evaporate liquid water to a gas. On larger systems, heated nitrogen can be flowed through the pipe to heat liquid water and force evaporation. Can vacuum damage refrigerant oil? Myth or fact? Will refrigerant oil be damaged by vacuum? No, this is myth that has been going around the industry for some time. According to refrigerant oil engineers and testing, vacuum does not damage refrigeration oil until the pressure of the systems is well below 10 microns. Busted. Okay guys, one more time. For vacuum, we need to have vacuum machine, vacuum gauges, hoses, vacuum hose, removal tool. That's it. In my practice, when I finished to repair some systems which had leak, sometimes vacuum time more than half hour, and if vacuum it's very slow, what usually I did, the first time I try replace oil. If it doesn't help me, I will try connect it to nitrogen tank and put nitrogen gas in the system. Sometimes I did this job 1, 2, 3 times before start vacuum again. This is how it looks like vacuum. We supposed to be did vacuum after we are installed systems, after we are repair some leak of the systems. That's it. Do you have question?
No.
No. Sounds good. Yeah. Bye bye. Thank you.